All right, taking a look at the last page of our review, you'll see that I've already created my segmented bar graph for my data. Your data might be a little bit different than mine, but the concepts are going to be the same. Now, notice segmented bar graphs, I'm going up to 100%. I said every 4 is 25 because, you know, I gave you a nice weird number of tick marks here. Sorry for that. But based on this, we want to know, do we think grade and the number of correctly identified Disney villains is associated or independent? Well, again, what we're looking for here is more or less similar bars or similar segments of this graph. Now, the one thing that I didn't include here is my key. So I am going to do that, and we'll say that I did that on purpose just to make sure that you all were paying attention. So let's say, and I also didn't label here, just to make sure that I highlighted it in this video for sure, not because I was rushing. So for our key, this is going to be 0 to 6 correctly, and I forgot the C there, but that's all right. Movies. For my hash, it's going to be 7 to 14 correct movies. And then our last one is going to be nothing filled in. That's going to be our 15 to 20 correct movies. So if you create a segmented bar graph on there, make sure you include a key. Right. So, do we think that grade and the number of correctly identified Disney villains are associated or independent? Well, for my data, yours might look different. For my data, it looks like they are because we have such big differences in our data values here. So, based on the segmented bar graph, it appears grade level and I'm going to use a little shorthand here, number of correct movies and I'm going to say may be associated. We can see a larger proportion of underclassmen were able to identify 0 to 15 or 15 to 20 correct. And I might include the actual proportions from 8 and 9 on there to justify that as well. So that might be one thing that I would add to this, is give an actual percentage since I calculated those. However, if we don't know exactly, like if I was just given the segmented bar graph, I would say this would be satisfactory. Or just the fact that these bars are different would also indicate that there's an association. All right. Jumping down here now, we're comparing these two data sets to each other. I'm going to let you read through mine. So the one thing you would want to make sure that you include here is our comparative language. So greater than, less than, similar to, that sort of stuff. So make sure you include that when you're writing about the similarities and differences of these box plots. Let's play around. So when we're looking at box plots, each segment of the box plots represents 25% of the data. So we're going to keep that in mind as we work through 13 through 15. So approximately what percent of students in period 4 got more than 8 correct? So we're looking at period 4. Hey, 8 correct is my median, so more than that would be up here. 25 plus 25 would give me my 50%. Approximately what percent of students in period 3 got less than 7 correct? Well, we're going to call this 7 right here, so less than that. That would give me 25%. And if there are 20 students in period 3, how many got between 7 and 15? Between 7 and 15, well, that's going to be 50% of my data, so that would be 10 individuals. Okay. So that's kind of how you work this. Just remember box plots is 25, 25, 25. One thing to keep in mind is this Q1 value is not included in the data that's above. This median value, again, is 25 below, 50 below and 50 above, not including this value. Right? Periods 3 and 4, here's our means and our standard deviation. So which class was more consistent? Well, we look at the standard deviation when we're talking about consistency. And remember, this is the average distance from the mean, so the smaller the standard deviation, the closer my data points were to the mean on average, and that would mean that they're more consistent. So period 4, because the standard deviation is smaller. Calculate our combined mean. Well, we don't have an equal number of individuals, so our combined mean is going to be the mean of data set 1 times its sample size plus the mean of data set 2. In this case, I should have used 3 and 4 but that's okay. We'll let x bar sub 1 be the sample size from period 3, and n1 be x bar sub 1 be the mean from period 3, and n sub 1 be the number of individuals, and then period 4 for x bar sub 2 and n sub 2. In this case, we're taking 11.5, multiplying that by 20, and adding 12.1 and multiplying that by 25, and dividing all of that by 20 plus 25. When we put that into our calculator, we get a value that I'm going to tell you momentarily. No stalling happening whatsoever here. Mr. Whitesell's on top of it. You're probably all yelling the actual answer at me right now. You're taking so long. There we go. About 11.83. And points, right? Oh no, movies. All right, hope you found that helpful. Sorry for the little delay there in my calculating at the end. Looking forward to seeing some awesome test scores. So have a great rest of your day, and I'll see you for the test.